let's introduce the first two trigonometric functions. Now that we understand angles and know what a unit circle is, we can put them together to define sine and cosine. Both of these terms deal with exactly where the terminal side of an angle touches the unit circle. Specifically, the sine of an angle is the y value on the point where the terminal side of the angle hits the unit circle. Let's make that a little more concrete. If we imagine our initial angle along our positive x-axis and our terminal angle marked by the angle t right here, then sine of t, sine of this angle, is just the y-coordinate of this point right here. Similarly, cosine of this angle, cosine of t, is the x value of this same green point. As it says in the equation, x equals cosine t, and y equals sine of t. And this will be true no matter how big the angle t is. For this angle here, once again, we're assuming that our initial ray is along the positive x-axis, and our terminal ray goes out along this red line. Since this is a unit circle, we know that the length of that line segment is 1, but what we care about is the coordinates of this point. They're labeled here as 0.111 for x and 0.994 for y. Therefore, we can conclude that sine of t is the y-coordinate, 0.994, and cosine of t is the x-coordinate, that's 0.111. We'll notice that we don't even know what this angle t is in degrees or in radians, but we can still tell what sine of t and cosine of t are because the coordinates are given to us. Let's take a look at this example here. We'll notice t is a much bigger angle now, starting from the same initial ray and going to the final ray. As before, we don't actually care how big this angle is. We just want to find sine and cosine of t, which are the x and y coordinates of that point. Therefore, we know that sine of t is the y-coordinate -1/2, and cosine of t is the x-coordinate -√3/2. As we've seen, both sine and cosine can take on positive and negative values depending where along the circle our angle puts us.